Hello everyone. Today I, Anvita Mahajan, along with my teammates Saili Mate and Yashodhara Haribhakta, would like to present on the topic University Recommendation System using collaborative filtering. So the current trend is that we observe a steady rise in Indian students applying for postgraduate programs in USA. However, this application requires careful planning and it is a really difficult process as there are numerous factors like academic performance, GRE TOEFL score, research experience, publication, work experience, university rating, budget, etc. involved, and thus there is a need for a robust algorithm with high accuracy which can recommend the universities to the students based on their profile.
The literature review will help us understand what work has been done till now in this domain. So the existing research explores various algorithms which include support vector machines, k-nearest neighbors, and decision trees for university recommendations. Various features like GRE score, GPA, TOEFL score, along with university budget and rank have been considered for university recommendations. Some research also prioritizes the factors like GRE and GPA, which allows for targeted recommendations that best align with the student's academic profile. Regression algorithms like linear regression, support vector regression, as well as their comparative analysis has also been implemented. Furthermore, hybrid models that combine collaborative as well as content-based filtering have been developed. In addition to that, stacked ensemble models which utilize large data sets have also been implemented. So after thoroughly analyzing the literature review, these are the research gaps that have been found. The first one is availability of data. A significantly large data set for recommending universities is not publicly available. The current recommendation systems are built on data sets that are either limited to less than 50 universities or have very few instances. So availability of data becomes a major challenge. Second one is the models used. As we saw in the literature review, various ML models like SVM, KNN, and decision trees were utilized for university recommendations. Although the implementation of artificial neural networks in university recommendations still remains unexplored in this field. And third one is the feedback system. There are very few recommendation systems that have implemented a feedback system. They have kept a track of successful applicants in order to validate the recommendations given by their systems. However, they haven't used the feedback for future recommendations. Hence, implementing feedback system for improving model accuracy still remains a gap.
While exploring different portals which recommend universities on the basis of profile, we observed that even ChatGPT does so. However, there are some flaws in its results. First is that ChatGPT does not give admit percent for the recommended university. It only gives the list of recommended university. Next, if we give the same prompt for the profile 2 or 3 different times, then the list of universities obtained each time is completely different. And lastly, it does not recommend based on entire profile. That is, even if one of the aspects in the profile is very high, then still it recommends top tier universities when that is not the case in reality.
This is a design model of our system. So first we have done data scraping, then pre-processed the data, then found out weights of the feature in the data set in order to find the most important features. Then using these features along with some additional features like budget, minimum test scores, and university ranking, we have built a model for university recommendation. We are also validating our recommendations with respect to the actual admits. And finally, there is a feedback system which helps to improve our model accuracy. We have scraped our data from the website known as the gradcafe.com. After scraping, we had almost about 25,000 entries in our dataset, and the features that we extracted were as follows: university name, result, which described whether the candidate got admitted, rejected, or was on waiting list, the term and year of admission, GRE, AWA, Quant, and Verbal are the three aspects of the GRE score. Undergraduate GPA of this candidate, TOEFL score, the postgraduate degree that the candidate wants to pursue, and finally research experience, work experience, and publications.
So while pre-processing the data, first we handled the missing values by removing them in order to avoid any kind of ambiguity in data. Next, we pre-processed the data by making all the university names uniform, as there were some university names where abbreviations were used. Later, we converted the categorical features to numerical, and then we normalized the data and resampled the data as our data was highly imbalanced. So this slide shows the graphs where the data before resampling as shown in the figure is highly unbalanced. So these graphs are frequency versus university name, and the data was resampled on the basis of university names.
Feature selection. So feature selection plays a very important role in recommendation system as it helps to identify the features that are significantly contributing to the system. So we have implemented various methods here, such as the Pearson and Spearman correlation and analysis of variance, that is ANOVA techniques, which calculate feature weights using statistical methods. On the other hand, Gini index, XGBoost, and ANN find feature weights as a part of the model training process itself. After finding the feature weights with all these methods, ranks was given to the features to highlight their importance. And then based on these ranks, the feature weights were found out by calculating the sum of all the ranks of each feature followed by normalization. So here we can see that GRE verbal, TOEFL score, and GRE quant are the top three features which are most related to the university name.
So this slide shows different types of recommendation systems. First is collaborative filtering. In collaborative filtering, recommendation is done on the basis of similarity of the profiles. In content-based approach, the recommendation is done on the basis of historical preferences of the user. And lastly, a hybrid model comprising of both collaborative filtering and content-based approach. Here we have used collaborative filtering. Within collaborative filtering, we have focused on model-based approach, where we have used deep learning techniques for recommendation of universities. So this slide shows specifications of the ANN model that we have built. First, we have trained the model for 30 epochs and training testing split is 80-20. The number of dense layers chosen were 5. And the activation function is ReLU, optimizer is Adam, and kernel initializer is Glorot normal, so as to mitigate the issue of vanishing gradient which occurs in ANN. And lastly, metrics used is accuracy. So this slide shows why 5-layer architecture of ANN was used. So we started with a single layer and went on increasing the complexity of the model, and we observed that 5-layered architecture gave highest accuracy with minimum overfitting, and that's why it was chosen.
So along with university recommendations, we also have a feedback system. After the recommendations, we ask the user whether they were satisfied with our recommendations or not. If not, then we ask the user to fill out a form and list the universities that they were expecting to get admit into. But since these are the expected universities, we first ensure whether the user profile is actually suiting the criteria of the university or not. This feedback is then used to update the feature weights and improve the model accuracy by retraining the model. However, the model is updated only if it exceeds the accuracy of the previous model. These are the results of our university recommendation system. Our training accuracy came out to be 92.02% along with testing accuracy of 91.02%. The precision was 91.03%. recall 91.06%, and F1 score 91.01%. From this graph, we can see as the number of epochs increase, the training and validation accuracy also tend to increase. These are the results given by our recommendation system. So after filling all the information like GRE score, TOEFL score, GPA, and other factors discussed earlier, our system gives top 20 universities that are most suitable to the profile. It also gives the overall admit percent that is mentioned here. We have also done manual validation. For that, we have scraped 200 profiles from the website called Yocket of academic year 2024. Then we compared the actual admits with our recommendations and found the accuracy, which came out to be 58.33%. Our contribution in this research is that we have created a university recommendation data set which consisted of 58,000 entries. The data set is publicly available on Kaggle. We have also designed a custom model for university recommendations.
Thus, to conclude, while working on this project, we were able to create a sizable data set of 28 lakh entries. We were able to identify high impact features which result in admit or reject. And lastly, we were able to build a novel model which falls under model-based collaborative filtering recommendation type. The future scope of this project includes considering SOPs, LORs, and resumes while recommending the universities, as these three also form a crucial aspect while getting an admit. Next, implementation of a robust feedback system using reinforcement learning. And lastly, including demographics for personalized recommendations. So these are some of the links which we have accessed while working on this project. Thank you.